Hello friends, today we'll discuss draw the Bode plot for second order system. So drawing the Bode diagram is specifically for checking the stability of a system. Suppose if you wanted to check the stability of a system, one of the technique for checking the stability is Bode stability criteria. So if you wanted to apply Bode stability criteria, first thing is you have to plot the Bode diagram. So we'll see how we can plot the Bode diagram for second order system. For any system, if you wanted to draw the Bode diagram, first thing is you have to know the transfer function. So for a second order system, we know the transfer function as g of s is equal to kp divided by tau square s square plus 2 zeta tau s plus 1. At the same time, you should know the amplitude ratio and phase angle also. Otherwise, you have to derive the amplitude ratio and phase angle for a second order system. So that will be taking a long time. So therefore, better to remember the amplitude ratio and phase angle for corresponding systems. So for a second order system, the amplitude ratio and phase angle is given here. Then next is the plotting the graph Bode diagram is actually it consists of two graphs. So one is magnitude plot and the other plot is phase angle plot. So both the graph we have to draw it in the same graph sheet. So first graph is log AR versus log omega graph. So that means we wanted to know how the amplitude ratio varies with respect to the frequency omega. Similarly, the second graph is phase angle plot. We wanted to know how the phase angle varies with respect to the frequency omega. So if you wanted to plot a graph, so we'll be considering only 3 points. So that is when omega tending to 0, omega tending to infinity, and omega tau omega equal to 1. We'll be considering only these 3 points, and by considering these 3 points, correspondingly we'll get amplitude ratio and phase angle. By using that, we can plot the graph. So that is the procedure. So first thing is, first will substitute when omega tending to 0. So if you substitute AR is equal to Kp divided by root of 1 minus 0 square plus 0 square. So you will be getting AR is equal to Kp, and AR by Kp, if you take the ratio, it is 1, and that 1 normally in Bode diagram, the log AR is representing in decibel. So in order to convert this value into decibel, what you have to do is you have to take 20 log AR. So here 20 log instead of amplitude ratio, here we are getting the value as 1. So therefore 20 log 1, the value becomes 0. So we represented the value 1 in decibel, it is 0 decibel. So next is phase angle. What happens to phase angle? Phi is equal to tan inverse of, wherever you are seeing omega, there you substitute 0, and then you will be getting phase angle. Phase angle as we are getting 0 degree. So another thing is, second case is, so first we substituted omega tending to 0. The second we are substituting omega tending to infinity. So when you substitute omega tending to infinity, amplitude ratio AR is equal to Kp divided by denominator becomes infinity. So actually that cannot be solved. So therefore you have to take logarithm on both sides. So when you take logarithm on both sides, it comes like this. And so we can apply the logarithmic rules, and log y is equal to log x. So this term you can take it into the another side. And the another thing is here omega value is infinity. When you compare infinity and 1, it will be a very small value. And here omega raised to 2, here omega square raised to 2. So this term will be very higher. So therefore you can omit the other two terms, and then you can keep this term as the dominant term. So if you solve, you will be getting log AR by Kp is equal to minus 2 log tau omega. So from this, you can conclude that, so this equation is in the form of a log y is equal to m log x. So it is a straight line equation having the slope minus 2. So when omega tending to infinity, what you have to do is, you have to plot a graph, plot a straight line with a slope of minus 2. So coming to the phase angle. So phase angle is, again you substitute the value of omega as infinity. Then at that time you will be getting phase angle is minus 180 degree. So here I consolidated the data, because if you wanted to draw a graph, so that should be tabulated. So I represented the result in a table. So far we applied only two conditions: omega tending to 0, omega tending to infinity. So at that time, AR by Kp I am taking into the y-axis, because Kp will be a constant value. So therefore, Kp I am including in on the y-axis. AR by Kp, when omega tending to 0, AR by Kp value is 0 decibel. When omega tending to infinity, we are not getting any value. Instead of that, we are getting a straight line with a slope of minus 2. Phase angle is 0 corresponding to omega tending to 0, and minus 180 degree corresponding to the radiant frequency of infinity. So next is the last case when tau omega equal to 1. So when you look onto this equation, so there is one more parameter in the second order system, that is a zeta. So zeta also we are assuming it as 1. So if you substitute all the values in the amplitude ratio equation, you will be getting AR is equal to Kp divided by root 4. Root 4 is actually 2. So AR by Kp is actually 0.5. And if you convert it into decibel, you will be getting it as minus 6.02 decibel. So finally we wanted to find the phase angle. Phase angle is equal to, again in that equation you substitute tau omega equal to 1 and zeta equal to 1. You will be getting the phase angle as minus 90 degree. So all these values, these three cases I tabulated in a tabular column. So by using this tabular column, we can plot the graph. So coming to the graph. So in graph, what you have to do is, so you take the graph sheet, semi-log graph sheet, and fold it in the middle, and the top portion you can use it for magnitude plot, and the bottom portion you can use it for phase angle plot. So magnitude plot, it is a graph of actually log AR versus log omega, but here Kp is a constant, so that also incorporated into the y-axis. So it is a graph of log AR by Kp versus log omega. And the phase angle plot is phi versus log omega. And next is, we wanted to mark the y-axis scale and x-axis scale. So x-axis scale, it is a semi-log graph sheet. So therefore, half portion is logarithmic scale. So the x-axis is logarithmic. Logarithmic value, I am marking it as 0.01. So corresponding to the 1 on the top of this graph sheet, and 0.1, so corresponding to the next one on the top of the graph sheet, and corresponding to the next one, I will be marking it as 1, next one 10, and the next one it will be 100, and like that it goes. So next is, if y-axis scale. So y-axis in magnitude plot normally will be writing in decibel, and the center portion you can mark it as 0 decibel, and the top portion you can mark it as 20, 40, 60, 80 decibel, like that. And the bottom of 0 we can mark it as minus 20, minus 40, minus 60, etc. And the y-axis scale is a normal scale, so therefore appropriately you can fix the scale. And next is how we can plot the magnitude diagram. So first condition, when omega tending to 0, AR by KP value we are getting 0 decibel. So therefore you can draw a straight line at 0 decibel when omega tending to 0. So here you cannot find 0. Here you cannot find 0. You can find only the lowest value of omega is 0.01. So therefore, this you can consider it as omega tending to 0. So corresponding to that, that value is 0 decibel. And the last condition is when omega tending to infinity. So here omega tending to infinity means in graph sheet omega tending to 100 is the maximum value. So that can be considered as the omega tending to infinity. Okay, so next is how much length I should draw this 0 decibel line. So for that, so there is a corner. So for finding the corner, omega equal to 1, tau omega equal to 1, we assume that is a third case. So correspondingly, omega is equal to 1 by tau, that is 1 by 1. So corner we are getting it as 1. So till 1, omega equal to 1, you can draw the straight line with a 0 decibel. So after that, you have to draw a straight line with a slope of -2. So for plotting -2 decibel till -40, this is -40 decibel, and this gap is this much till here. This much gap is 20 decibel. So -40 divided by 20, it will be -2. So therefore, from here, draw a straight line connecting this point. That is the magnitude plot. Phase angle plot is when omega tending to 0, phase angle is 0. When omega tending to infinity, phase angle is -180 degree. When tau omega equal to 1 or omega is equal to 1 by tau, that is at that point phase angle is -90 degree. So we are having these 3 points, join the points like this. So this is the phase angle plot. So the same way for any system, you can draw the Bode diagram. Thank you.